In this session, we are going to discuss hypothesis test for equality of two population means for large samples. And the questions that we are going to discuss or included in this topic are 10.2 and 10.6. These are the same questions that we did discuss in the class. So starting with question number 10.2 that focuses on the survey conducted from two different categories of graduates, accounting graduates and liberal arts graduates, and they had been asked about their annual starting salaries. So the data that we are given for accounting and liberal arts graduates in this table are in thousands of dollars. So if the value is mentioned as 29.3, it does reflect or represent $29,300. In the question, in part A, we are asked for, as the 5% significance level, can we conclude that accounting graduates have a higher mean starting salary than the liberal arts graduates? Assume the population standard deviations of starting salaries are 1.73 for accounting graduates and 1.82 for liberal arts graduates. Note that the sum of the accounting data is 887.6 and the sum of the liberal arts data is 892.9. So what we can do, based upon the given sums, when we divide these sums by the number of observations given for each data set, we can come up with the mean value. So I'm going to note down the data first. The data are N1, the number of accounting graduates is given as 32, while N2 is given as 35. Now as far as sum of X1 or sum of the salaries given for 32 graduates is 887.6, and sum of X2, which is for liberal arts graduates, is given as 892.9. So we divide by the number of observation and we get the sample mean values as 27.74 and 25.51. Sigma 1 is given as 1.73 and sigma 2 is given as 1.82. Now we are asked to perform the hypothesis test that accounting graduates are getting higher salaries on the average as compared to liberal arts graduates. So accounting graduates data is first in order, therefore it needs us to perform a right tail test, so that mu1 is greater than mu2. In the null hypothesis we state it as mu1 equals to mu2, and this implies that when we restate it in the form of difference between the two, so when two things are given equal, their difference is 0. Now the next step is to state the level of significance, which is alpha equals 0.05, that's what we are given. Then we go for defining or choosing the test statistic appropriate for this hypothesis testing, that is z equals x1 bar minus x2 bar minus mu1 minus mu2 divided by square root of sigma 1 square on n1 plus sigma 2 square on n2. Now in the next step we will define the critical region or the rejection criterion, or the condition under which H0 would be rejected. So since it is following a z distribution and z distribution follows a bell-shaped curve, so we draw bell-shaped curve. We select 5% area under the right tail region and mention the probability of 0.05. If we refer the z table for the probability of 0.05, so z 0.05 is 1.645, and this is how we mention here as the condition H naught would be rejected if z calculated is greater than 1.645. This region we can indicate as the non-rejection region for H naught, and this region as rejection region for H naught. Now, in the next step, we go for computation. And we make substitution of values here. That's 27.74 minus 25.51 minus, in place of the difference between two population means, we have to take 0 as mentioned over here. Divide this by sigma 1 is given as 1.73. Don't forget to raise it to square because we are given standard deviations. So divide by 32, then 1.82 squared divided by 35. Now you can substitute. We have substituted and we can now work out the answer. Okay. The answer, I believe, must be falling in the rejection region as 27.74 minus 25.51 gives us 2.23. So that's the numerator value. Now I'm going to work out the answer for denominator. So the answer for divisor or denominator factor is 0.4337. So when we divide 2.23 by 0.4337 equals 5.414. So 5.14 is the computed value. Now we write down decision and we compare where does this value falls. It is falling clearly in the right tail rejection zone. Therefore H naught is rejected. So we write it down as, since Z calculated falls in the rejection region, yes, RR represents rejection region, therefore H naught is rejected. And we state our conclusion as we have performed a test and we got the result. So we state it as the test results are, since we have rejected H naught, therefore we state it as are statistically significant at the 0.05 significance level, and data provide sufficient evidence that the mean starting salaries of accounting graduates are higher than that of liberal arts graduates. This is how we can state our conclusion. Now moving to the next question from the same topic, that is about two dieting programs. So research studying obesity wanted to compare the effectiveness of dieting programs with exercise to dieting without exercise. 73 patients were randomly divided into two groups. Group 1, composed of 37 patients, was put on a dieting program with exercise. Group 2, composed of 36 patients, dieted only. The results for the weight loss in pounds after 2 months are summarized in the following table. So the mean weight loss for the first group is 16.8 pounds. Its standard deviation is 33.5 pounds. And the mean weight loss for the second group of patients is 17.1 pounds. And standard deviation is 5.2 pounds. In part A, we are asked for, at the 5% significance level, determine whether there is a difference between the two treatments. So again, I'm going to note down the data. The question number is 10.6 and N1 is 37, N2 is given as 36, X1 bar is given as 16.8 and X2 bar is given as 17.1. Now S1 is given as 3.5 and S2 as 5.2. Over here you can take notice of one thing, that standard deviation of the populations are not provided. Rather, standard deviations of sample observations or data S1 and S2 are provided. But if you look at the sample sizes are larger enough to go for Z distribution for the hypothesis testing. And this time we are asked for that there is a difference between the two treatments. So difference, the word difference requires us to go for a two-tailed test indicating not equal to sign in the alternative hypothesis. Now we mention level of significance. We need to divide it by 2, the level of significance, because we are performing a two-tailed test. And a slight amendment is desired in the formula because we are not given population standard deviations. So we use sample standard deviations in the formula in the denominator. So that's S1 squared divided by N1 plus S2 squared divided by N2. And now we state or define critical region. We draw bell-shaped curve. Point 0.025, 0.025, non-rejection region for H naught, rejection region for H naught, rejection region for H naught. H naught would be rejected if Z calculated is either less than minus 1.96 or it exceeds plus 1.96. As usual, in the next step we go for computations. (16.8) minus 17.1 minus this difference is again 0 mentioned in H naught divided by 3.5 squared. Again, don't forget to raise standard deviation values to square. So that's 5.2 squared divided by 36. And we will now going to compute the numerator and denominator values. So that's 16.8 minus 17.1 is minus 0.3 and then square root of 3.5 squared divided by 37 plus 5.2 squared divided by 36. That's 1.04 is the answer in the denominator. So 0 minus 0.3 divided by 1.04 gives us minus 0.288. And that's clearly the case of non-rejection because it is falling within this limit of minus 1.96 and plus 1.96. So we write down decision accordingly as since Z calculated does not fall in the rejection region, therefore H naught is not rejected. And we write down the decision conclusion as the test results are not statistically significant at the 0.05 significance level, and data do not provide sufficient evidence to conclude that there is a difference between two treatments. So that's